double-threaded binary tree. This is an example for double-threaded binary tree. In this tree structure, every node will be having the left thread and right thread also. If there is no left child, left thread will exist. If there is no right child, right thread will exist. If left child exists, then no left thread can exist. If right child exists, then no right thread can exist. And one more case is like leftmost node in the tree structure will not have the left thread because it is not having any predecessor. And also rightmost child in the tree structure will not have right thread because it will not have any successor. Okay, so this is how the double threaded binary tree will be. And if you observe in this particular tree structure, the successor of 10 in the in order traversal is 18. That is, after 10 we will get 18. So the right thread of 10 will be connected to 18. Then because 18 is having left child and right child, it will not have any threads. And coming to 21, because the 18 will be coming before 21, the left thread of 21 will be connected to 18 and 25 comes after 21. So right thread of 21 will be connected to 25. Then goes with 25. Left 25 is having both left child and right child, so no threads will be existing. Similarly 34 also is having both left child and right child, so it will also not have any threads. Coming to your 29, before 29, 25 will come in the in-order traversal. So left thread of 29 will be connected to 25 and 34 comes after 29. So right thread of 29 will be connected to 34. And coming to 40, because 34 will be coming before 40 in the in-order traversal, left thread of 40 will be connected to 34 and there will be no number or a node which comes after 40 in the in-order traversal because it stops with 40. So that is why the right thread will not exist for 40. Now, let us see how we can create and insert nodes in the double-threaded binary tree. So starting with 20, because there is no tree structure at all, 20 will become the root. Then 10 is less than 20, so 10 will be inserted as left child of 20. And because 20 will be coming after 10, the right thread of 10 will be connected to 20. And because 10 is the leftmost node in the tree structure, it will not have any left thread. Then 30, because it is greater than 20, it will be inserted on the right side of 20, that is as a right child of 20. Now 20 comes before 30, so the left thread of 30 should be connected to 20 and 30 is the rightmost node in the tree structure, so it will not have any right thread. Then 5 is less than 20, 5 is less than 10, so 5 will be inserted as left child of 10. And now 10 comes after 5 in the in-order traversal, so right thread of 5 will be connected to 10. And as 5 is the leftmost node in the tree structure, it will not have any left thread. Then 16. 16 is less than 20 and greater than 10. So it should be connected as right child of 10. So when you are connecting 16 as right child of 10, but now at present there is a right thread. So if you want to connect it as a right child, the right thread whatever is existing to the 10, that will become as the right thread of 16. Because 10 will be coming before 16, the left thread of 16 will be 10. Now you can remove the right thread of 10 which is connected to 20 like this. Okay. Then 14. 14 is less than 20, so come towards left of 20, and 14 is greater than 10, so come towards right of 10, and 14 is less than 16, so it should be inserted as left child of 16. Now when you are inserting 14 as left child of 16, it is having thread already. For 16 is already having the left thread. So now what we will do? the left thread of 16 should be the left thread of 14, and because 16 will be coming after 14 in the in-order traversal, the right thread of 14 will be connected to 16. So here 14 will be inserted. The left thread of 14 will be connected to 10 because before 16 left thread is connected to 10, and then the right thread of 14 is connected to 16. Now you can remove the left thread of 16 which is connected to 10. Then next 17. So 17 is greater than 16. So it should be inserted as right child. But already right thread is existing. So what we do? Right thread of 16 will be connected to right thread of 17, and left thread will be connected to 16 because 16 comes before 17 in the in-order traversal. Okay. So 17 right child of 16, and you can observe left thread of 17 is connected to 16 and right thread of 17 is connected to 20 because right thread of 16 is connected to 20. Now you can remove the right thread of 16 which is connected to 20. This will be the updated one. Then finally 13 we are supposed to insert. 13 where it will come? It will be less than 20, greater than 10, less than 16, less than 14. So we are supposed to insert it as left child of 14. So when you are inserting it as a left child of 14, what will happen? The left thread of 14 which is connected to 10 will be left thread of 13. That is, left thread of 13 will be connected to 10. And because 14 will be coming after 13 in the in-order traversal, the right thread of 13 will be connected to 14. Now you can remove the left thread of 14 which is connected to 10 like this. Okay. Now let us see the insertion in the double-threaded binary tree alternate method to make the threads to be uniform. Actually, what we have discussed till now, the left thread of leftmost node will not be there because there will be no predecessor to it. At the same time, the right thread of the rightmost will not exist because there will be no successor to it, right? But to make the all threads in the tree structure to be uniform, that is, every node in the tree structure will be having the left thread and right thread. What we are doing, we will be creating a null node or dummy node we can say. So that is left thread of leftmost node will be connected to dummy node. Similarly, the right thread of rightmost node also will be connected to dummy node. So in this fashion we can observe now every node will be having either left child or left thread. Similarly, right child or right thread. Okay. Then deletion in double-threaded binary tree. How I will delete a leaf node in double-threaded binary tree? Now if you see here, we want to delete 13. 13 is a left child actually. So when you are deleting the left leaf node, what will happen? We are supposed to adjust your threads. Because 13 is the left child of 14, the left thread of 13 which is connected to 10 should be as left thread of 14 now. And you can delete the 13 because right thread is connected to 14 because 13 doesn't exist anymore, so it is not a problem. Only you have to adjust the left thread because 13 is the left child of 14. Like this we will adjust the left thread and remove 13. Okay. Then again we are deleting the leaf node, but you can see that we are deleting the right child. We want to delete 17 now. We want to delete the right child. So what will happen? You have to adjust the right thread. So the right thread of 17 which is connected to 20 should be connected as right thread of 16. So first we will adjust the right thread of 16 and then delete 17 completely like this. Okay. Then node to be deleted has only one child, means it could be either left child or right child. Now in this example we are seeing delete 14, that is a particular internal node which is having left node actually. Okay. So when we are deleting the internal node which is having the left child, 13 should be used to replace 14 actually, right? because it is having only single child. This is a process what we have discussed already in the case of binary search tree. Now, when you are replacing 13 in place of 14, that is nothing but the left child of 16 will become 13. So, first that connection should be established. Okay. Now, when you are saying that the 13 is the left child of 16, obviously the right thread of 13 will be 16. So, you will connect that also. Okay. And then now you can delete 14 completely. So 14 will be deleted like this. Okay. Then delete 17. Now we are trying to delete an internal node which is having the right child. So what do we will do now? The same process again. That is 19 will be used to replace 17. So 19 will become the right child of 16. So you establish that connection first. And because 16 will come before 19 in the in-order traversal, the left thread of 19 should be connected to 16. So left thread of 19 will be connected to 16 and 17 can be deleted now. So the corresponding code we are showing here. And next, finally, deletion of a node that has two child nodes. Now here we want to delete 16. So actually when you are deleting a particular node which is having two child nodes, either we can replace with the node from the left subtree or right subtree. In this particular case we are replacing with the right subtree. So what are we doing here? We are replacing 16 with 17. Now, but what is the procedure here? I am going to replace the 16 data only but not complete node actually. Okay. So 16 will be replaced with 17. Now this 17 is different and this 17 is different. Okay. Because in this node 16 is replaced with 17 data only. What do you mean by replacing data only? That is we are not modifying any threads actually. Okay. So now delete 17 using the procedure for deleting a node with single child. Previously we have seen how we have deleted 17. So what we have done in that case, 19 is going to made as right child of 17 actually. So you will establish that connection and left thread of 19 will be connected to this 17. So you will establish that connection and then you delete this 17 actually in which is a right child of 17. So that one will be deleted. Like this, we can delete a node that has two child nodes. The same process we can do by replacing 16 here with 14 also, because 14 is the maximum value of the left subtree. And here we have used 17 to replace 16 because it is the minimum value in the right subtree. Okay, either procedure you can follow. Okay, thank you.